Okay, this is a grade 11, November 2017 question on Newton's law of universal gravitation. Grade 11. It says to you, the acceleration due to gravity on planet X is 2.7 meters per second. 2.7 meters per second. This acceleration due to gravity on Earth, we call this little g. So on this other planet, this is the equivalent of little g. It says the radius of this planet is a third of the radius of Earth. So this planet is much smaller than Earth, and its gravitation is less than on Earth, because on Earth little g is 9.8. It says to you, explain the difference between weight and mass. So if you look down here, you can see this is what the memo says, but you should know that weight is a force, it is a vector, mass is a scalar. Weight depends on the gravitational force exerted on an object by the Earth or whatever planet you happen to be on, whereas mass is how many particles you have, the amount of matter in a body. So basically, if you know the definition, you can be using the definition to explain that answer. Now it says to you, calculate the mass of planet X. Now on your data sheet, there are two formulas, these two over here. Okay, sometimes you don't always get both data sheets, both formulas, but it's not a problem because you can work it out. Because in the first formula, you have the formula that F equals G m1 m2 over r squared. But if I were to take away this F, which is your weight, and replace it with mg, because that is what the force due to gravity is your weight. Okay, look at the definition. Weight is the gravitational force. What happens is this mass on this side cancels this mass on this side, and you are left with the formula G, little g, equals big G, big M over r squared. So even if your data sheet doesn't have the second formula, you can work it out, because the weight, which is mg, you remember the formula for weight equals mg. This formula is the same as the force in newtons on the left of the universal gravitation formula. Okay, so now if it says to you, calculate the mass of planet X, we're going to use the simplified formula for little g. So little g, the question tells you, the acceleration due to gravity is 2.7. Big G, we know from the data sheet. Here it is here. It's the universal gravitational constant, 6,67 times 10 to the negative 11, times the mass of the planet, which we are trying to find. So we should really call it mx, the mass of planet X, and then divided by the radius of the planet squared. So it says to you the radius of this planet is 1/3 of the radius of Earth. So you just write 1/3 of, because of is to multiply, and you go to your data sheet and you find the radius of the Earth, 6,38 times 10 to the power of 6. It's already in meters, so we're fine. And then make sure the 1/3 and the radius of the Earth are all inside the bracket when you square it. The radius is squared. This is the value of the radius of the planet, 1/3 of the radius of the Earth. So you have to square this entire value. And then, assuming you can use your calculator and no grade 8 algebra, you will end up with something that is like 1,83 times 10 to the power of 23, which is not a scary number. Look at the mass of the Earth here. It's an even bigger number. And remember, the units of mass are in kilograms. So that is the mass of planet X. Now in 5.3, it says determine the factor by which the weight of an object on planet Earth will differ from the weight of the same object on Earth. So when they say the factor here, this is a maths thing. They want to know what number, by what number is it bigger or smaller. So first of all, if we have a look here, this value, acceleration due to gravity, is 2.7. So it says determine the factor by which the weight of an object on planet Earth will differ from the weight of the same on planet X will differ from the weight of the same object on Earth. So to find the factor, we're going to go the weight of the object on Earth, okay? So the weight of the object on Earth over the weight of the object on planet X, okay? So what is the formula for weight? It is mass times the acceleration due to gravity. So this is mass times the acceleration due to gravity on Earth over mass times the acceleration due to gravity on planet X. Now, the mass of the particles on Earth and the mass of the particles on planet X is exactly the same. So those two cancel each other, and I'm left with the acceleration due to gravity on Earth over the acceleration due to gravity on planet X. So the acceleration of gravity on Earth, we get it from the data sheet, it's 9,8. The acceleration due to gravity on planet X is in the question, it is 2.7. And if you put those into your calculator, you get 3,63, okay? So the weight of the object on Earth, now make sure you answer the question, the weight of the object on planet X is 3,63 times smaller than the weight on Earth. Okay, so remember, if you think about this, if you want to figure out if it's smaller or bigger, look at your formula again. Which one is bigger, 9.8 or 2.7? So on Earth it must be heavier because you're multiplying the mass by 9.8. On the planet it must be smaller. So the factor is 3.63, and it is smaller on X than it is on Earth.